Okay, so we're on to kind of two of the last objectives, which are review. So some people in the other class were able to be working on the practice test today because you should get the work done today in class, and then we're doing one more tomorrow. You should get the work done in class. So Thursday is a short day, right? So the more you can get done ahead of time on that practice test, the better. Okay? Now today, we're just bringing it all together. And by that, I mean we are saying let's do all the things that we've been doing kind of separately. Let's do it all together. Now, the first thing that I think we've always learned, have known about since you've been in high school is asymptotes, okay? So, let's see that, I know, vertical asymptotes. Okay, so vertical asymptotes are the first thing you ever learned. Now, when will you have a vertical asymptote? See if you know. I don't really want to throw the last class under the bus, but no one in the last class knew when you have a vertical asymptote. I don't think it's a tough question. No. Yeah, there's an X in the bottom, and it doesn't cancel with anything on the top. Because what if it does cancel with something on the top? Point of discontinuity, right? So you've never done point of discontinuities really until now, so you're always thinking, hey, if there's an X on the bottom, it's not permissible, it must be a vertical asymptote. So after yesterday's lesson, I hope now you know not to just jump to that conclusion, because the answer is waiting for you to circle in the multiple choice if you do. And obviously, that's not good. Okay? Now, there's many ways to find out if it cancels. You can factor, you can graph, you can see no asymptote, therefore there must be something. So for the vertical asymptote, if you had like A plus B, let's go, sorry, X, I'll use X. So say I have X plus A over X plus B all over X plus C. This is when you'll have a vertical asymptote, right? And the vertical asymptote would be X equals so negative C is where you're going to have a vertical asymptote. So if I now go to the third thing that we learned, the point of discontinuity, it would look like this, X plus A over X plus B all over X plus A. So this would equal X plus B, and we would have a point of discontinuity at, so our point of discontinuity would be at minus A, comma, what would be the Y value? Negative A plus B. Okay, so that's why this is a good objective. Just kind of gets everything where you're seeing it all at one time. And then, kind of a separate entity is what we learned kind of second of this lesson, and that is the horizontal asymptotes. Now again, when you're making a study sheet, are you organizing your thoughts? Like I would put these two together on my study sheet, and I would write down, look for this. Make sure it cancels, you'll get a point of discontinuity. If it doesn't, then you'll get your... See, that's what the study sheet is meant for. It's not meant for, oh man, I hope I can just put all the information out possible, and I hope I get to use it. Okay? See, if you know it, then you don't have to use it. And the study sheet will help you know it, or will make you know it, if you just don't write stuff down as a, let's get all the crap on here possible. But if you start to write it down, and start to go, like, when will I use this? And you start making notes to yourself, and you start making little strategies and things to look out for, that's what learning this curriculum's all about. Okay? If you're just memorizing a ton of rules, you're going to find that you just can't put enough up there. Okay? So some of this stuff has to start actually making sense. Now, for horizontal asymptotes, we have three big rules. The first one, if the degree is less on the top than on the bottom, y equals 0 will be the horizontal asymptote. If they're equal, so say I have 2x cubed over 3x cubed, my horizontal asymptote will be at 2/3, right? And what about if the degree is greater on the top than the bottom? There will be no horizontal asymptote or an oblique. Okay, so you're never going to know if it has a vertical asymptote or point of discontinuity unless you actually factor the top and see if anything cancels. The fourth type, there's actually one more type of, and we're going to call it number 4 here, and it is a rational function that has no zeros, therefore would be no discontinuities or would have any asymptotes. And that's always hard. Like, you just do them, and you go, like, you can have an x on the bottom and it doesn't make the thing equal 0. Well, here would probably the best example I could give you. You see there's no x in there, that would be bad. Because no matter what comes out of here, it will be positive. And if you add 1 to it, it's still going to be positive. So there's nothing bad here. So x would be in the reals. So don't jump to conclusions. Again, get this one on your study sheet and have some good examples. Like, put 3 examples down that would not have a discontinuity in the bottom. And you're going to see often it's going to be a squared, because squared makes it positive. Now, and then you do these, and then I get this, and I get no discontinuities, and I go, yeah, there is. What if you put 1 in there? Mr. Trimble, you said if there was an x squared in the bottom, there would never be. And I said, no, I never said that. Okay. I'm saying that if there's an x squared, that's the only way there can be, or something to the 4th that makes it positive plus. So this would be called a non-example, okay? Because non-examples are just as powerful as examples. If you can put both of those on your study sheet, and there's always people that tell me, Mr. Rob, put that on my study sheet. I had that one there. Or, I knew on the last exam, people who didn't have that, if I got 5 right and 2 wrong. Remember that question I gave you on the test with the 5 winning numbers? I did that one right in your notes. And I had people that either said, yeah, I got that one down on my study sheets. And I got people that go, well, I didn't know I should write that down on my study sheet. Well, you didn't know it, so it should have been on your study sheet. Okay? So when you're going through your notes, you should try to get down everything you can that would be on the test. Because if you guys aren't thinking like the test, then you're not going to be ready for it. You're not going to be successful. And I look at it as if you were a car salesperson, and you were thinking like a car salesperson, not the people buying it, and someone came and you wanted to sell them that car. A salesperson would say, I want to sell you that car because I make commission. B, I need to get that thing off the lot. C, it's a piece of crap, and if I can get rid of it now, that would be just awesome. Would you make a sale? You wouldn't unless you start thinking like the person buying the car. What would they want? Okay? And a really good salesperson that sells cars is honest, but still thinking about how that is good for them. You know, that's good size for your family. I know that's a color you love. This thing is like we're trying to get it off the lot, so I have it marked down so much that I'm practically giving it away. See, that's where the person buying it is going, oh, those are good reasons for me to buy the car, not good reasons for him. Any salesperson that you can even start to see a little bit that this is more for you than it is for me, people don't like those kind of sales. They don't. Okay? So when you're making a study sheet, you got to think what would be on that test. This could be on there, and I don't know it very good, so I better get ready for it. Okay? So hopefully, and I know you guys are getting better and better at your study sheets because I've been looking through them and I'm seeing a lot of progress. And I just want you to kind of, this one, but this is another good unit, you guys. You can check things in your calculator if you know your rules well. The people that I am going to get on Friday are the ones that don't know those little things, right? These little rules. Now, we're actually just going to go right to do 2 examples knowing those 4 things. So I'm thinking vertical asymptotes, point of discontinuity, horizontal asymptotes, and no points of discontinuity. Now, here's an excellent question that, and you got to know your stuff if you're going to find out which one of these has no discontinuities, which has no vertical asymptotes, which has no horizontal, which has the x-axis, aka y equals 0, which one has y equals 1, and which ones have point of discontinuity. Okay? Now, here would be, you could number this 1 to 10 up top, and I could just maybe list 4 of those and, get that even on a numerical response. Maybe I'd only have 4 up top, and I'd say which one has no discontinuities. They're really easy questions if you know the rules, and they're like, oh man, I didn't even put that on my study sheet. I didn't study that. Right? So let's just, and you can see they're all A, B, C, D, E. So what we're going to do first, since we're only doing 2 examples, we're going to do these in detail. Let's try and factor all of them, because when we factor all of them, it gives us a bit more information. Okay, now A cannot be factored anymore, right? Can B be factored? What can be factored? Right, that's a perfect square. X plus 2 times x minus 2, and that's all over x squared plus 4. Okay? How about C? Same thing, kind of, right? So that would be x plus 4 over x plus 2, x minus 2. So this one takes a lot of prep before you can even get going on it down in the bottom questions. D looks like C, but when you factor this is x plus 2, x minus 2, you kill that, and you would say that's the same thing as 1 over x minus 2. And remember, this isn't really 1 over x minus 2. It is 1 over x minus 2 where x cannot equal negative 2. If you don't put this, then it equals 1 over x minus 2. And remember, it doesn't equal 1 over x minus 2. Like, I hope I've been kind of putting that down enough so you're going right, because 1 over x minus 2 would not have a non-permissible of negative 2, would it? Now, the next one, can I factor it? Nope, I'm not factoring that. F, I have x squared plus 4 over x minus 2, x plus 2. G, can I factor it? You take the negatives out, so that'd be negative x minus 4 plus 4 over negative x squared plus 4. So basically your negatives are going to cancel, just to give you x plus 4 over x squared plus 4. I think this one doesn't really, maybe you're seeing, well, I don't see a big advantage there. But you'll see in the next one there is a big advantage because this is negative x squared plus 4, and this is negative x squared minus 4. So the negatives will cancel again. So this will be x squared plus 4 over x plus 2, x minus 2. Okay, the next one, this factors 3x plus 2, x minus 2, and the x plus 2's cancel, right? So this is just going to equal x minus 2. X cannot equal negative 2. Okay, and the next one, can I do anything? I can take out an x here. That would be x squared minus 4x. I take an x out on the bottom. That would be x minus 2. Okay, x's would cancel, right? So that would leave me with x squared minus 4x over x minus 2. Now, since I canceled the x, what do I have to put? X cannot equal 0. See, that one's so much simpler than all the other ones, it's very confusing. When I cancel x minus 2, everybody's like, well, x can't be 2. That one's easy. I cancel an x, and the class goes silent, okay? Yep. Yes, it's true. Good. So that would be x times x minus 4. So I'm not really accomplishing too much, but that's right. I can do that. Okay, so I have done absolutely none of the questions so far. That took about 10 minutes. But yourself, all by yourself, I'm going to give you, it's 11:03, I'm going to give you till 11:08, see if you can get these right. We've done all the prep together. Do you know your rules? Okay, one more minute. It's good to see everybody here today. Impossible 33, perfect 10. It's always isn't easy. Okay, so I'm just going to get people to help me with these ones, and we'll see if they're right, wrong, or missing some. Okay, so Jamie Prinz, which one had no discontinuities? B and G. So what were you looking for? Yeah, an x squared and a plus, or something that is not going to have anything bad on the bottom. And B and G, are they the only ones? Is there another one? Okay, yeah, that's right. No vertical asymptotes. Alex, what'd you get for that one? D and I. Okay, let's look at D. Now, wouldn't it have two? It's going to have an asymptote at, oh, sorry. It's going to have an asymptote at 2, isn't it? So this is this one's going to have a point of discontinuity, but it will still have an asymptote here. That's a mixed, it's like a hybrid. It has all of them, vertical, horizontal, and has a point of discontinuity. Okay, well, I agree with I. This one would not have an asymptote. That would have a point of discontinuity. So I agree with I, but I think we would have to put B and G in there too, right? Because B and G they have no discontinuities, therefore they would have no vertical asymptotes. Okay, so I want to know what you were looking for when you were looking for C, and then tell me the answers. Graham, what were you looking for no horizontal asymptote? Good. So which ones were that? Good. Okay, so y equals 0 as an asymptote. Again, what were you looking for and what'd you find? Jamie. Okay, if the degrees bigger on the bottom, what'd you get? G, C, D, G, right? We're going to put them in alphabetical order. C, D, and G. Okay. Now, what if I had a horizontal asymptote of y equals 1? Nancy, what were you looking for? Okay. Okay, really good. Okay, and which ones have points of discontinuity? What were you looking for to know if it did have points of discontinuity? Brianna? Yep. D, I, and you're missing one. it is the tricky one. Right here. Right? Because an x canceled. Remember, x is canceling are the same thing as an x minus 2 canceling. Okay? So, maybe I caught a few more people that would have got it wrong on the test. Hopefully I caught everybody, right? But I don't know if you can catch everybody all the time. Questions? Yep. Right here.
You know, for D, since the x-axis is a horizontal asymptote, how do you know that's with 0?
Horizontal is a horizontal asymptote. Actually, I don't. Oh, sorry, right here. The x-axis is y equals 0.
Oh, okay.
No, it's when a variable cancels out. Good question. Yep. B and G had no... Yep, B would, right? Because they're both x squareds. So if they're the same, they have a horizontal asymptote. The only time you would have no horizontal asymptote is if the degree is bigger on the top than on the bottom. So there is tons of stuff to know there, okay? So a good study sheet is going to do two things. It will get you through the exam on Friday, but more importantly, you can pick it up again when I give it back to you. And then when you read it, I know people are going to be, when they do the first practice diploma, no one reads over their study sheets first. They're like, and even today you're going to have to do things that we did 4 units ago. And I get students coming up going, what does this mean again? I don't remember what this means. Okay? So hopefully you've got a study sheet you could pull out and you would know exactly what that means. Okay? Now, we're going to do just one more example together. And again, this one is an excellent example. I mean, if you hear me, when you put, you'll see when we're done, you'd go, yeah, I would put that on a written response. Okay? So just anything like example 2. So I have no problem at all telling you guys exactly what's going to be on the exam, right? Because you're going to sit down and learn it. And I don't miss anything on my exams. I make sure every single skill is tested and on my quizzes. So it's like, oh, they went and learned all the stuff that I taught them and did it right on the exam. That sucks. Okay? Think about it, that's my goal, right? So I'm telling you, because I need my goal to be fulfilled, and that's that everybody gets and learns all the stuff for the test. So what we have to do is we got to find any asymptotes, any points of discontinuity, and then everybody's favorite, the domain and range. Okay? So this question is everything that we have learned for the last 4 objectives. The first one was was radicals. And there's no radical stuff in here, but this is all rational. You need every one of the last objectives, except for radicals, to be able to do this one. Now, the first thing that I would do, I would factor the bottom, because I'd want to see if there's any points of discontinuity. And I know that because it canceled. Now, look how nice. Top was factored already. I have to admit, I would not be that nice on a test, okay? I'd make you factor the top and the bottom. So this one, I would factor the top and I'd factor the bottom. What would it be? X minus 5, x plus 3. Okay? So this would cancel, and I would be left with 2x minus 1 over x plus 3. X cannot equal 5. Okay? Now, let's do asymptotes first. Okay, so vertical asymptote. Do I have a vertical asymptote? Yes, at where? You guys, talk to me. Where? X equals negative 3. Very good. Now, you've learned something today, I think, that's new, is that if I still have something on the bottom that didn't cancel, that's going to be my vertical asymptote. That has to be an X, of course. I just had a 5 in the bottom, doesn't matter. But anytime I have an X in the bottom, so I want you to look at this thing right here. that has a vertical asymptote at negative 3. Now what about a horizontal asymptote? What would it be? Y equals 2. How are you getting that? Right. If you multiplied these together, it would be 2x squared. And that's over the 1x squared, so that would give you a horizontal asymptote of 2 over 1. So you know, it being all factored, that's not awesome for horizontal asymptotes. You'd like it all multiplied together so I could find the x squared. So factoring is not a good help to find horizontal asymptotes. You have to multiply it all together to find out x squared, what number's in front. So, yes. You have to use the original. Yeah, it's a good question. It works out coincidentally here, but sometimes it could fail you. No, seriously. Because if the 2x minus 1s would have canceled, I would have got this one wrong if I would have looked at my factored one. So it's not a good example in what you just brought up. Students can start to make generalizations just off this one, and the generalization they made is, hey, why can't I just use this one? Okay, because probably half the time it'll be wrong. Okay, you have to use your original. It's a good question. Okay, now I've got all my vertical, all my horizontal. What about point of discontinuity? What point is that? It's at 5, comma. Can't hear. No, I don't get 5 over 8. Okay, now here's another. You've never had to do this before. I'm going to take this 5 and I'm going to put it into both the top and the bottom. So that would be 2 times 5 minus 1 over 5 plus 3, which is 10 minus 1, 9 over 8. Okay, so I found my vertical, my horizontal, my point of discontinuity, and then I'm just doing domain and range now. So let's talk about domain. X cannot equal five. That's it. Negative 3 is bad. Range. Nine over 8. How do you get 2? Now, last class didn't like this one very much. Okay? Why do you think there's a controversy about 2? Because it can, now not always, doesn't have to, but it can cross the horizontal asymptote. So should I put 2 or not? The answer is yes. You put 2. Now how do I know that? How would you know that? At some point, but it doesn't matter. If it crossed it, it can be 2. Okay, Lana's kind of got the secret going. So what do? Graph it, you guys. Put this in your graphing calculator, and you tell me if it can be 2. Now, do you see how you really got to be on your game when you're writing the diploma? because I think too often we're just going, well, I don't know that one, so they got me in that one. I'll give them that one. I'm going to give them that question because I don't know. Okay, I'm going to guess on it. But I believe that I think you could always just graph it. This is where you're going to see people get out in the atrium and they're literally fighting. It's not 2. Yes, it was. Like, I graphed it. Did you graph it? No, I didn't even graph it. Here, I'll show you. And people are, and it gets kind of heated out there because when you get it wrong, or you just have to defend your answer, right? Because if you're wrong, that sucks. So you're doing everything to try and prove that it's right. So what they basically do is they just come running to me and then find out. Okay, so then I got that in. I hit zoom 6. Now you're going to see that it never crosses it. Okay? If it crossed it, it would go up, and if you can go, y equals 2. You can graph that. You can see, like, it's not going to cross there. Sometimes they go up, and they go here. So, I mean, why would that question be asked? Like, that's mean. That's a mean question. It's actually one where you just have to sit and think, or not, you have to think of a way to be able to find out if it's going to work or not. You got a question?
So, if it were the horizontal code, would you not put the 2?
I would not put the 2 in the range. No, if it crossed, I would not put it in. But yeah, I would not put it as a non-permissible. I would put it as a permissible. Yes. It's basically saying that the horizontal asymptote is 2, so y can't equal 2. But what I gave you that really, see, and remember, what's that 80 to 100? This is between 80 and 100. Like, they want you to see, do you know the rule that it can go through sometimes? Maybe they're going to give you one where it does go through, so only you'd put 9/8. You would not put 2. But you could see the multiple choice, right? You can see what it looks like already. One's going to have 2, the other one's not. And that's what the fight in the atrium is going to be about, okay? And don't worry, it doesn't get ugly, right? But one person definitely loses that battle, okay? And you're defending your mark. Like, that's what you're doing. You don't realize it because some computer's going to go mark it, but you have to yourself, like, please, I hope I got that right? So, as soon as someone says, I just graphed it didn't go through, and you're going, crap, I didn't even graph it, right? Well, that's the difference between the 80 and 100 student, right? The 80 and 100 student's going to graph it and look at it and verify it, right? And by that, you could see the difference between the last 2 exams was 10% average, about. You guys went down from 94 to 84 because you couldn't check it as well. There weren't nice ways to check the last one. You just kind of, and a lot of people were surprised by their mark, either good or bad. Whereas the one before that, people knew what they had. Like, I graphed every one of those, right? So this is back to that kind of unit where if you can graph it, make sure you do it. Okay, so you're doing 1 to 5.